All right. 6.3. Properties of trig. So it's trig from this point forward, as I've mentioned before. It's trig, trig, trig. Nothing but trig is left for us. And the test, exam number 4, it stops at 6.4. I don't know where else how it else on it. Oh, what is it? 11.1. Yeah, it started at 11.1. 11.1 all the way to 6.4. That looks backwards, but that's how we did lecture. So 6.4 is the last section. So we'll almost finish 6.4 today. So you will have seen almost all the material. Okay. Cotangent of 420 degrees. How do we do it? What do you remember? This notice it says do not use a calculator. So there'll be part 1, part 2 again. Part 1 will be no calculator. So you'll have to be able to do things like this with no calculator. So how do we do cotan 420? We're going to use our unit circle, right? So you will have. Oh, did everybody get one of those? I got some more. You pass that out. Unit circle. Anybody lose there? Didn't get one before. Need another one? I got lots of them. Unit circle. Pass it out. Everybody got there? Go and grab that out. If you don't have that, you know. Everybody got one? Unit circle handout. Okay. It's on the web page as well. So let's do that. So cotan of 420. Let's go there. Where is that thing? Is that it? Yeah, there it is. Okay, so there's the unit circle. So we're trying to do the cotangent of 420 degrees here on problem number 1. So what do we do with 420 degrees? Yeah, we subtract that's more than a full circle, isn't it? That's more than 360. So you just back up a full circle. So subtract 360, what does that leave? 60 more? So that's really 60 degrees, which is right here. So it's this dot right there. Remember, that's how you find sine, cosine, tangent, that kind of stuff? Okay, so it's that dot. It's at 60 degrees on the unit circle. Totally write this unit circle on your 3x5 card for the exam in a week. Have that right on there. Yeah, Marlon.
Print a little tiny one and stick it in there?
Yeah, whatever you want to do. Yeah, absolutely. Yeah, you can print anything you want that fits on that card. Yeah, so 60 degrees right there, that dot. Remember now so how do we do it? What's the half, right? The half is the cosine, and the second one's the sine. Remember that? Whenever you have the two numbers at any dot for an angle, the first one's cosine, the second one's sine. That's probably the most important thing to know about using the unit circle. The first, the point, the xy point on the unit circle, this dot right here, his x and y coordinate, the x is cosine, the y is sine. Okay, well, I'm trying to find cotangent. So you'll have on your 3x5 card, or maybe you already know, the definitions, right? What's the, so sine, what's the upside down of sine? Cosecant. And what's the upside down of cosine? Secant. And the upside down of tangent is cotan. So you'll have those on your 3x5 card maybe. And so you know what the reciprocal functions are, the upside down functions are. And how do you find tangent? It's sine over cosine. It's y over x, in other words, right? And we've done that before, haven't we? Things like that. Tangent is y. It's like a slope. Tangent's like a slope. Y over x, rise over run kind of thing. Sine over cosine. Okay. So what now? Well, because I'm trying to find actually cotangent. So what's if regular tangent is sine over cosine, what's cotangent? Upside down, huh? Cosine over sine. Just upside down of tangent, isn't it? Okay, so cosine, a half, over sine, root 3 over 2. So the cotangent there at 60 degrees is cosine a half over sine, root 3 over 2. Now we got to flip the fraction on the bottom. I'm going to bring it back now that we've got it that far. Are we good to there? This making sense? So cotangent of 60 degrees, which is the same as 420, right? Because everybody gets that, right? 420 just means 360 around and 60 more. 420 starts here at 0 and goes 360 and then 60 more. So 420 is the same ending place as just 60 degrees. And so it is, whoops, I already forgot what it is, a half over root 3 over 2. So it's a half over root 3 over 2. You grab that fraction on the bottom, flip it up. So it's a half times 2 over root 3. We good to there so far? The 2's cancel. It's 1 over root 3. And what do we do now with that square root in the denominator? Multiply top and bottom, right? By root 3, and we get root 3 over plane 3. And there we go. Never needed a calculator. So that's how you do it on the exam, part 1 of the exam in a week. Just like that. You'll have that unit circle on your 3x5 card, and just grab it that way. Good? You stop me if you want to talk more about it. Okay, so secant of 26 pi. Okay, so let's go to the unit circle yet again. So 26 pi. So where's 26 pi? Any ideas? Where we're going to find 26 pi?
Multiply by 180 over pi to take out.
Oh, convert to degrees, you mean? We could. And normally I do. Normally, because I totally feel more comfortable in degrees as well. But this one's pretty easy, isn't it? Can you tell where this one is? 26 pi. Where is that?
It's just 360.
Yeah, right. Isn't that 13 times 2 pi? That's just 13 full revolutions. It's just right here. It's just back at 0, huh? Is that okay? Does that make sense? That's just 13 full circles. 2 pi is all the way around. Right here. Right here's 2 pi right here. See? It's 360. 2 pi is 360. It's all the way around. So that's just 2 pi 13 times, isn't it? That just means they've gone around 13 times and stopped right where they started. It's exact full rotations. And so that's all we got to do. Now, secant, what do we do for secant there? What is secant's definition again? Yeah, it's 1 over the cosine, isn't it? It's cosine upside down of cosine. You have that in your 3x5 card if you don't already know it. So remember, the x is cosine, the y is sine. The 1 is cosine, the 0 is sine of the point where you stop for 2 pi, which is the same as where we end up, 360. So cosine is 1, so the secant, therefore, is 1 over 1 is 1. And we're done. Good? Questions? Right. So cotangent of 13 pi over 3. What should we do with that? Well, I don't know. That's a big angle. We should subtract. That's more than all the way around, right? That's more than 2 pi, isn't it? So what you should do is subtract. I mean, you can convert to degrees if you want to, but really we just need to subtract full rotations. Subtract 2 pi to get it down within 1 rotation. Is that making sense? So if I took 13 pi over 3 and I subtract 2 pi, just to kind of break it down, I want to get it under 2 pi because I want to get it within 1 rotation. Then I can go find it on the unit circle. You don't have to convert to degrees because I gave you all the pi stuff right on the, I gave you that one off the internet that has the pi stuff on it too. So let's just subtract 2 pi. And then how do I take 13 pi minus 2? This is like subtracting 360, right? Subtracting a full rotation. Does that make sense? Put this over 1, right? Common denominator, so multiply top and bottom by 3. So this would be 13 pi over 3 minus 6 pi over 3. 6 pi over 3 is just a fancy 2 pi. Subtract that, you get 7 pi over 3. Now, is that still more than 2 pi? Yes, it is. 3 goes into 7 more than 2 times, huh? So do another 7 pi over 3. Now subtract 2 pi again. Subtract 6 pi over 3, which is 2 pi. Again, and you get 1 pi over 3, or just pi over 3, huh? Does that make sense? So really what they're asking us is the cotangent of pi over 3. See how we got down to that? I just kept subtracting 2 pi. Just keep subtracting 2 pi until you get an angle that's under 2 pi. So now we're at cotan of pi over 3. Let's go to the unit circle and find, and what's cotangent? Remember, cotangent is cosine over sine, as we looked at a minute ago. It's being upside down of tangent, right? Let's go to pi over 3 on the unit circle. Where's pi over 3? Right there. Pi over 3. And so I'll say, okay, it's this dot right here. Here's cosine. Here's sine. Cosine is always the x. Sine is always the y. So it's a half for cosine, root 3 over 2 for sine. So a half for cosine, root 3 over 2 for sine. That's the same thing we did a minute ago, isn't it? Grab that denominator, flip it up. A half times 2 over root 3. The 2's cancel. 1 over root 3. We can't leave a root on the bottom. It's all the same stuff. Multiply top and bottom by root 3. We get root 3 over plane 3. And we're done. There we go. Questions on that? Is that okay? Is this making sense? All right. I'm going to keep moving. Okay, does anybody know the saying, remember from Trig, how you know like where the different trig functions are positive and negative? Does anybody remember that? There's like a saying to help remember that. All students take calculus. Yeah, didn't your trig teacher give you that? All students take calculus, right? It's a true fact. All students take, no, it's not true fact. But anyway, it's a little saying. All students take calculus. So you just do it, first, we do it in the order of the quadrants. First, second, third, fourth quadrants, as they're named. I don't know why we made them counterclockwise, but they did. They just made them that way. Well, I guess that's how the angles open up, huh? Yeah, because 0, you start there, and yeah, okay. So that makes sense. All students take calculus. So now, what does that mean? All students take it. Well, it's a way to know which trig functions, like sine, cosine, tangent, and the other ones, are positive and negative where. How's it work? That means all 6 are positive. All 6 trig functions are positive in the first quadrant. Guess what? In the second quadrant, guess what the S stands for? The sine, right? So the sine is positive. And of course, his upside down, his reciprocal function, which is cosecant. So that means in the second quadrant, sine and cosecant are positive. The other 4 trig functions in the second quadrant are negative. So that when we say that all students take calculus, we're saying which ones are positive, so the other ones are all negative. So sine and his upside down are positive in the second quadrant. In the third quadrant, what's the T stand for? Tangent and his upside down are positive. The other 4 are negative in the third quadrant. And in the fourth, cosine and his upside down secant are positive. The other 4 are negative. So that's a quick, easy way to know what the signs are for the different trig functions in the different quadrants. We good? All students take calculus. Those are the ones that are positive. They're all positive in the first. Only sine and his upside down in the second. Only tangent and his upside down in the third. Only cosine and his upside down in the fourth. Okay, so here we go. Which quadrant are we in? Sine is greater than 0, which is a way of saying positive, huh? Sine's positive. Now, right away, as soon as they say sine's positive, we're down to 2 quadrants. Which 2 could we be in so far? We could be here, where sine is positive, or the first, everything's positive, right? Next fact, cotangent is negative, less than 0. So if something's negative, I'm not in the first, because they're all positive in the first. So I must be in the second quadrant. Is that good? Are we happy about that? Here's the really important question. Why do we use Roman numerals to label the quadrants? Why do we say quadrant 1, quadrant 2, quadrant 3, and quadrant 4? Why do we use Roman numerals? Why don't we just say 1, 2, 3, 4? Like that. I really have no idea, but I just think it's a funny observation to make. It reminds me of one of my favorite Far Side. You guys remember that cartoon Far Side? That guy died, didn't he? Was it Larson? What's his name? Anyway, I thought he was hilarious. And there's one of my favorite ones, is he said, you ever thought about doing math in the Roman system? The Roman numeral system? You know, like Roman numerals? You know what I mean? You ever thought about that? Like, do anybody know anything about Roman numerals? Like, how do you make 10? What's 10 in the Roman numeral system?
X.
The X, right? So how do you make, like, 15? XV. And then I think L is 50, or D is 50. D is 50. I don't know it all. Anyway, but there's this one Far Side. You know, they had M's 1,000. M. You know, DL. I probably butchered it up. Minus. Think about this. And the other one was, you know, like X. You know, XXX. V 111. You know, like look at that. I mean, things aren't even lined up. Things aren't even, and they showed this one, you know, Gary Larson, the Far Side guy. He showed this one Roman guy with, you know, trying to do this with a very confused look on his face, and the caption read, "Another reason Rome fell." I thought it was pretty well said. You know, all the famous reasons why Rome didn't last. It was their math system. Another reason Rome fell. All right, I enjoyed that. Hopefully you did. All right, so let's move on. Secant is less than 0, and the sine is less than 0. Try to find which quadrant you're in. All students take calculus. All students take calculus. I'm sure Rome's on my mind. Over Thanksgiving break, my brother-in-law was over, and we rented Gladiator. Have you guys seen that? It's one of those. I wanted to show it to my 14-year-old boy. It's like a rite of passage, one of those man movies about battle and honor and all that. So it was all about Rome. And so Rome is on my mind, I'm sure. All right, all students take calculus. So secant is negative. Where is secant negative? What is secant? Secant is upside down of cosine. Yeah, so if you know, that's basically saying cosine's negative. They're the sine. Secant and cosine are the same sign. They're just upside down of each other, right? Reciprocal functions. So if secant's negative, so is cosine. So cosine's negative, so we're not here. And we're not here because they're all positive here, and cosine's positive here, and they're telling me cosine's negative. So we're not in those two quadrants. We're not in the first or fourth. Okay, sine is also negative. Sine is negative. So we're not here because sine's positive in second. So where are we? We're in the third, huh? Roman numeral 3. Good? All's well, easy. All students take calculus? Okay, so they're giving me sine and cosine, and they want me to find the other 4 trig functions. Let's start with tangent. Yeah, let's start with tangent. Perfect. So how do we find tangent? What's the definition for tangent? Sine over cosine. Cassandra, the ladies' tennis team won, right?
Tennessee?
Did I say tennis? I'm always thinking about tennis. The soccer team. Yeah. The soccer team won, right? So what was the score? I mean, Erica told me I didn't get the score, though.
2-0.
2-0. Boy, you guys shut out almost everybody. Is the only team to score on you this year, Clovis?
No, we've been scored on by a couple other teams.
Okay. Anyway, so the ladies' soccer team plays the semifinals Friday. Erica told me, right? Mm-hmm. Friday, right here, like 2:00 or Oh, no, the finals are in Sacramento, aren't they? Oh, the semis also?
Yeah.
Oh, they're both in Sacramento. Oh, what a bummer. I wanted to come on Friday. So they're both in American River College? Wow, okay. All right, well, anyway, so very exciting. Semis and the finals if they win Friday and Sunday. And the men's team is still alive too, right?
Yeah.
They're, same thing, they're in the Final Four?
Yeah.
And where do they play? Not here, huh?
Same place.
Oh, it's all American River, huh? They have a big facility there? Even though you guys just beat American River like a week ago or something. They're out, but they're still hosting. Okay. All right. All right. Congratulations. That's exciting. All right, so tangent is sine over cosine. So sine over cosine. So negative 3 root 10 over 10 all over cosine root 10 over 10. Like that? Good there. And then you just grab that cosine in the denominator and you flip it up. So negative 3 root 10 over 10 times 10 over root 10. And boom, and a boom, and a boom, and a boom. It's just minus 3 after all that, isn't it? So we got tangent. So now we want to get the other 3. You know how to get them. They're just up, just flip it, flip it, flip it, right? The other 3 are just upside down, upside down, upside down of these main 3. So, for example, cotan. So if tangent is negative 3, what's cotan? Negative 1/3, right? Just upside down. And if sine, come up here for sine. If sine is this, what's the upside down of sine? Cosecant. Cosecant is just flip that upside down. Like that. But we can't leave that root in the bottom. So we got to get rid of that. So let's do that. Root 10, root 10. So we get minus 10, root 10. On the bottom, we get 3. And what's root 10, root 10? Plain 10, and these 10s cancel, and it's minus root 10 over 3. And so that's cosecant, and then cosine, flip over cosine, you get secant. Secant, flip it upside down, 10 over root 10. What do we do with the square root on the bottom? Multiply top and bottom by root 10. We get 10 root 10. Root 10, root 10 is plain 10. These cancel. Root 10. Easy enough? So they give me sine and cosine. Tangent is just sine over cosine, and then flip it, flip it, flip it. All right, I'll move on. So this is where we'll spend a little more of our time. So they're giving me cosine of theta. Can you read that? I want to make it a little bit smaller to have room. In fact, maybe I was going to go to a fresh screen. And they want all the trig functions. Yeah. So this is number 9. I'm just going to go to a fresh screen. 9. They're telling me cosine of theta is what? Negative 24/25. And they're telling me quadrant 3. Theta in quadrant 3, and they want me to find the other trig functions. Okay, so there we go. There's number 9. So this is going to be a fair bit of work. You've probably done these before, but it's probably been a while, and these are more complex. So first thing we need to do, what we're going to do is we're going to draw an axis system, and we're going to put the angle on. Oh, you need a test from me, huh? Okay, have a seat. I'll grab it just a minute. Put the angle in quadrant 3. Okay, so quadrant 3, so down here, I'm going to put the angle in that position. Now, when I make this angle, remember, do you remember from your trig days, that you always want the angle theta going to the x-axis, not the y. This is really important. Everybody hearing me? I'm not doing the Charlie Brown for you, the wah-wah-wah teacher voice right now, right? You're hearing me? Because this will really mess you up. If you put it here, ball game over. It's over. Can't do that. You've got to put the theta between the line and the x-axis, right? This is the x-axis, right? It's got to be, now why? Why has it got to be the x? Well, I don't know if you remember from your trig days. It's called reference angle. Remember that word? You got to make it the same reference angle. Why? Why there? Why not the y? Why can't that be the reference angle? Because x started to 0 degrees. It's the x-axis where 0 degrees begins. So that means any angle off the x-axis, it's going to be the same reference if you're off the x-axis in another quadrant. So in other words, if I come 30 degrees if I'm wondering what's the sine, cosine, tangent, whatever, of 30 degrees, whatever it is, it's going to be the same sine, cosine, tangent of 30 degrees off the x-axis, really in any quadrant. You can go here, go 30 off the x, you can go here, go 30 off the x. You're going to have all the same trig functions except for the sign. You know, plus, minus, other than plus and minus. The sine, cosine, tangent, the numbers will be identical. We call that a reference angle. If you do the same angle off the x-axis, in any other quadrant, you're going to get all the same trig functions, sine, cosine, tangent. They're all the same other than positive, negative. And we determine that with all students take calculus. That's easy to figure out. So remember that? That's called a reference angle. If you do the same angle off the x-axis with reference to the x-axis, referring to the x-axis, if you do the same angle off the x-axis in any other quadrant, it's the same as what it would just be in the first. So that's why we just say, hey, whatever, just put it wherever, but then just go look at it in the first. It's the same answer other than the sign. Okay, so we say, all right, we're in quadrant 3. Get rid of these. We're in quadrant 3. I'm going to put, it's not 30 degrees, it's theta. I don't even know what theta is. I never will. I don't need to. So theta is some angle off the x-axis in quadrant 3. And then you make a right triangle to the x-axis again. It's all about that x-axis in quadrant 3. And then you make the cosine fact true in that little right triangle. What am I talking about? Do you remember adjacent, opposite, adjacent, hypotenuse, that whole thing? Let's do that in this little right triangle. Which side is the hypotenuse? It's the longest side, the diagonal side, the side not touching the right angle. The other two hit the right angle. So this is hypotenuse. Okay. Now, from theta's perspective, which is the side next to him? Well, the x-axis up here, right? These two sides, the hypotenuse and the side above him, are touching the theta. That means that's the adjacent. Adjacent just means next, like your neighbor lives adjacent to you, next to you, right? From my perspective, Tyler is adjacent to me. He's next to me. It just means who's next to you. So from theta, you know, if I put theta down here, then this side would be adjacent to theta, but we're never going to do that. Theta is always at the origin with the x-axis. So this is adjacent. So what does that mean this side over here is? This is the, whoops, that thing just moved on me. Is opposite, right? We good like that? Now, and then how, okay, so great, so what? Well then, remember the trig functions? Remember SOHCAHTOA? That whole thing? SOHCAHTOA, that's how you know the sine, cosine, tangent kind of stuff. Okay, so we're talking cosine. Cosine is what? Adjacent over hypotenuse. So that means this is adjacent, and this is hypotenuse. The 24 is adjacent, and the 25 is hypotenuse. You tracking with me? So that means this is minus 24, and the hypotenuse is 25. Does that make sense? Why is that minus 24? Well, there's minus on the fraction, and it's back. So, of course, it's negative. You always make the hypotenuse positive. Now, really, if you want to, you could just ignore the negative, positive stuff and just figure out the sign in the end with all students take calculus, right? That's what when I taught my daughters pre-calc a year ago, I think I told you they had Mr. Jameson. I would do these problems with them, and I would always tell girls it's back and dads, and they go, whatever, Dad. We just like all students take calculus. So if that's easier for you, great. We know tangent, in this quadrant, tangent and his upside down cotan are going to be positive. The other four are going to be negative. So if you just know that, you don't even need to play around with signs. That's going to be the signs in the end. You can just do it that way. All right, anyway, whatever you want to do. So far so good. Cosine is adjacent over hypotenuse. So and this is adjacent. This is hypotenuse from theta's perspective. Now, can I get this other side over here? Pythagorean, right? That's what you do. And then once we have all three sides, we can get all the trig functions. We can get anything we want. So let's just get that other side. Pythagorean. So 24 squared plus whatever you want to call it. I'll call it y or b, or maybe I'll call it b. Whatever. A squared, b squared, c squared. 24 squared plus b squared is 25 squared. Is that good? Remember, the hypotenuse is the one that goes alone when you do the a squared plus b squared is c squared, right? Use your calculator. Is that 576? And this other side is 625. Am I doing that right?
Yeah.
And then subtract 576. So b squared is 49. So b7, right? Root it, b7. So this side is 7. Technically, it's -7 because it's down. But like I said, if you want to just ignore those signs, you can fix them later. Does that make sense how I found that? Mm-hmm. So again, I just put theta to the x-axis, made a right triangle, said, look, cosine's adjacent over hypotenuse, so 24 over 25. Once you've got two sides in a right triangle, you find the third by the Pythagorean. Now, I can find anything they want, any trig function they want. What do they want from me? Well, they want, what did they want? First, they wanted sine. They want them all. So first, they want sine. So I go, okay, you want sine? What is sine? Right there, sine, so katoa, so opposite over hypotenuse, right? So what's opposite? It's the 7 over hypotenuse. It's technically the -7. -7 over the hypotenuse, which is 25. -7 over 25. And upside down of sine is cosecant, so that would be -25 over 7. And then what else do we have? They gave me cosine already, so upside down of cosine would be secant, right? Am I going too quick? You guys with me? That makes sense, right? So I just said sine is opposite over hypotenuse. Got it. Cosecant's upside down to that. They gave me cosine, so upside down to that is secant. What I got left? Tangent. Tangent, toa. Opposite over adjacent. So what's that? Opposite over adjacent. -7 over -24. Two negatives make positive. And sure enough, we knew, didn't we, in the third quadrant, tangent's going to be positive. So like I said, you can just ignore all the little signs in the triangle if you want, because there's too much to worry about. That's how my daughters felt. And they would just say, whatever, Dad, we'll just fix the signs in the end, because we know it's third quadrant, tangent's going to be positive, and so's his upside down, cotan, going to be positive, just upside down. And the other four are all negative, and sure enough they are, aren't they? And there we go. So that makes sense. This is super important. Be two of these, probably on at least two of these on the next exam, I would say. Yeah, probably two. Probably straight two, just two. Really important, really, because you'll use this in calculus, and we'll have it again, and I think it's in the next section. Anyway, there's really important processes, making these triangles and doing this whole thing. Very, very important. Is that good? See how that works? Questions? Should we try one? Okay, so there you go. All right, let me just go to a fresh screen. This is number 10. So number 10, and they're saying cosine of theta is -7/8. And theta is between pi and 3 pi over 2. So, oh, it's so similar. What quadrant is it in? What does this mean, pi and 3 pi over 2? Theta is between pi and 3 pi over 2. Where's that?
Third.
It's third again. Does everybody see that? If you look at the unit circle picture, if that helps you, you can always go to that unit circle picture. Right here. Here's pi, and here's 3 pi over 2. So it's somewhere between these two. It's third quadrant, huh? Third quadrant. So it's third quadrant again. So same thing. It's almost identical. I wish they'd made it a little different. Go ahead and try that real quick. See if you can whip that out. They want you to find the other trig functions. So go through the same thing. All right, how we doing? Cranking this out. So put your angle theta. Remember, it's always to the x-axis like that. This is going to be adjacent, hypotenuse, opposite. It's all the same, huh? SOHCAHTOA. SOHCAHTOA. Cosine's adjacent over hypotenuse. So adjacent, hypotenuse adjacent is -7. Hypotenuse is 8. So now we got to find the other side. So -7 squared plus b squared is 8 squared. So what's that? 4 dead. It's going to come out like not clean, huh? So that's a little different, I guess. It's 11 to 15. So b is the root of 15. So b is, it's technically negative because it's down, but you could skip that and do the signs later if you want. That's the opposite side there. It's negative root 15 because it's down, but again, you could skip that and just call it root 15. That's fine. Good. You guys get root 15 there? And now we can get all the trig functions, right? Maybe I'll do one or two of them and move on. So you could do sine, for example. What's the sine? Opposite over hypotenuse. Opposite over hypotenuse. So opposite over hypotenuse. Negative root 15 over 8, etc., etc. We could get them all. Is that okay? I want to move on to one a little different. If you're good with that, no questions, I'll move on. Okay. So secant of theta, well, I'll just get a fresh screen again. Number 11, secant theta is 3. Okay, so number 11, secant of theta is 3. Cotangent theta is greater than 0? Yeah. Secant theta is 3, cotangent theta is greater than 0. All right, try that one. Actually, let me help you as you get going. Find out what quadrant. You always want to start with which quadrant. You want to draw the thing in the correct quadrant. Make the triangle, in the correct quadrant. Which quadrant are we in? Let me give you a second. So, secant is upside down of what? Secant is the upside down of cosine. So they're saying secant is positive 3, so that means cosine is positive. Okay, sounds good. So cosine is positive. Cosine is positive. So where's cosine positive? All students take calculus. Could be here, could be there. Right, because all are positive in the first quadrant, cosine's positive there. And cotangent is greater than 0 positive. So cotangent is also positive, so we're not in the fourth. Because only cosine and his upside down are positive. The other four are negative. So that's not where we're at, since cotan and tan are positive. Also, we must be in quadrant 1. Good? So we're in quadrant 1. That's their way. And now you can just forget about this. The whole purpose of that was to help you know which quadrant you're in. Now we know, we'll forget about that. So we are in quadrant number 1. Quadrant number 1. And put your angle theta, and I'll let you go from there. So take it from there. Okay, so now secant of theta is 3. That means cosine is 1/3, doesn't it? Let's go to the upside down fact right away. Secant is 3, so cosine is 1/3. And then we know the whole SOHCAHTOA. So cosine is adjacent over hypotenuse, yet again. So looking at now this angle theta, so this is the hypotenuse. This must be the adjacent side because it's next to theta. This is the opposite side. It's across from theta. So therefore, when they say cosine is adjacent is 1, hypotenuse is 3. So there we go like that. So now we do the Pythagorean over here. So we got 1 squared plus b, so we call this b or whatever, equals 3 squared. Do the Pythagorean to find the third side of the triangle. 1 plus b squared is 9, subtract 1. B squared is 8, root it. B is 2 root 2. Is that okay? The root of 8 is 2 root 2. Simplified. Remember how that works? When you get the root of 8, you break it down. 2 times 2 times 2 is 8. 2 2's in, sends 1 2 out, the other's left in. So 2 root 2. So B, right here, is 2 root 2. Okay. So now we can get any of the trig functions they'd like us to find. So the sine of theta, sine is opposite over hypotenuse. So that's opposite over hypotenuse. 2 root 2 over 3. I could find, and you can do the rest. Okay, let's go dot, dot, dot. You could find any of them. Do you remember that from your trig days? Do you like seeing math a second time? I always liked seeing it a second time. It made more sense for me the second time. Like, oh, it didn't seem so bad all of a sudden. I don't know. That's how math always felt very painful. First time, like, what are they doing? Why are they doing that? And then second time, it's like, oh, okay. That's not too bad. Good? Questions I can answer? All right, so number 13, cosecant of negative 45 degrees. All right, they're talking about using even, odd properties. We have talked about even and odd functions, but it's been a long time, and I'm sure you don't completely remember all the details about it. Let me mention this. I don't know if I doubt anybody would remember from your trig class about sine, cosine, tangent being even and odd. Anybody remember that? I'd be very impressed if you did. Here's what it is. Cosine and his upside down, they always go together, are both even. And the other ones, sine and his upside down, cosecant, tangent and his upside down, cotangent, are all four odd functions. They're odd functions. So what? What in the world does that mean? Anybody remember what an even function means? What does it mean for an even function when you plug in a negative? When you plug a negative whatever into an even function, the negative vanishes. Anybody remember that? That's a good reminder to study for the final because that is something we covered, but it's been a long time. It's hard to remember all this stuff. You really need to study for the pre-calc final we have in 2 weeks because there's a lot to remember. So that's what it means to be an even function. That's what we're saying. If you plug in negative, for example, if you take the cosine of negative 30, it's just the same as the cosine of regular 30. The negative, you can just erase it. It does nothing. That's what it means to be an even function. It's the same answer. Negative. The negative doesn't matter. And what does it mean to be an odd function? You plug in a negative, the negative goes to the front. So it doesn't vanish, but it goes to the front. That's what we're talking about here. Cosecant is right here in the list of odd functions. It's an odd function. So this negative that they've plugged in, where's it going to go? It's going to jump to the front. Now you might think you could always do that, but you can't. That's not always true for every trig function. But it is true for the four odd trig functions, sine and tangent and their upside downs. So the negative just jumps to the front. That's what they mean when they say use even odd properties. The fact that he's odd lets the negative jump to the front. If he was cosine, the negative would just simply vanish. That's what it means to be an even function. Now, having said all that, really, who cares? It's not the biggest deal in the world. You could just do the problem leaving the negative in there, and it's fine. The real question is, can you do this problem on the unit circle? Because there's no calculator. Over here off the screen it says do not use a calculator. So this will be on the no calculator part. So let's go to the unit circle and let's find our answer. So there it is. So what are we doing? We're doing the cosecant of 45 degrees. Let's go find 45 degrees right here. Here's the dot. That means this is cosine, this is sine. Which one do we, right, the x is cosine, the y is sine. Which one do we use for cosecant? We use the sine, huh? Of course, they're the same. It doesn't really matter, but it would always be the sine. Cosecant, so this is negative upside down of the sine. Negative upside down of the sine, right? So it's negative 1 over root 2 over 2. How are we doing? Am I losing you? How are we doing? So I went to the unit circle for 45 degrees. Here's the cosine, here's the sine. Grab the sine, root 2 over 2. Said, okay, negative came to the front. Cosecant 45 is 1 over sine 45. So now grab that fraction on the bottom, flip it up. Negative 2 over root 2 when it flips up. Cannot have a root in the bottom. Multiply top and bottom by root 2. Negative 2 root 2 over plane 2. Right at the bottom, root 2, plane 2. The 2's cancel. Negative root 2. That okay? So what did we do again? Cosecant's an odd function, which means the negative goes to the front. Cosecant's 1 over sine, went to the unit circle, sine's root 2 over 2. Flip it up, get rid of the root. There it is, negative root 2. Now, having said all that, if you want to, I probably, if I was you, if I was a student taking this class, I'd go, who cares about that even odd stuff? I don't need to give myself more work to do. I'm just going to do this negative 45. You don't need to move the negative to the front. You can just leave it in there and get the same answer. That would be easier, I think. If you're comfortable with negative angles, and I think probably most of you are. Where's negative 45? I mean, there's no negatives listed here, but you all know where it's at, huh? Where's negative 45 actually?
Right across from 45.
Yeah, it's down 45, right? Negative angles are down. So really, you could just leave the negative in there. You don't have to do the even odd, move it to the front thing. If you're comfortable with negative angles, you can just say, look, negative 45 just means down 45 instead of up 45. Down 45 from 360 be down to 315. It's the same. It's this spot. It's the same thing, huh? And and here's the cosine. Here's the sine. Notice what the sine is. Negative. So there's our negative. Root 2 over 2. So just do that, flip it, same answer. And you don't have to worry about the even odd stuff and try to remember all that stuff. Just do it that way. Probably easier. Is that good on that? Questions on that? All right, so they want cosine of negative 90. If you want to just leave the negative in there, that's fine. Go ahead and just go to the unit circle and just leave the negative in there and don't worry about the even odd stuff. Or if you want to, you could do the even odd stuff. Do something with that negative sign. Okay, so I'm just going to go to the unit circle. So negative 90. Where's negative 90? Down 90 degrees would be right here. Is that good? Because negative angles are down instead of up, right? From 0. So down, because here's 0. So down 90, negative 90. So here's the cosine, here's the sine. What do we want? Cosine. 0. Done. Now, if you wanted to do that, so that's fine. That's all you have to do. There's the answer. We're done. If you want to do the even odd thing, you could have said, well, look, the negative inside, this is an even function. The negative inside just vanishes or becomes positive. Remember that for even functions, cosine's even. Negatives just vanish, just become positive, in other words. And so it's going to be the same as cosine of positive 90. That's what it means to be an even function. You get the same answer, they're saying, if you just do the positive angle. Is that true? Yeah, because positive 90 is right here. See how the cosine is exactly the same answer? Either way. Good? Questions on that? 0 either way. Probably don't remember all these because they're small little details from trig. You might remember that one. Anybody know can you do that? Again, no calculator notes. This could be on the no calculator part. So if this was on the, no calculator part, could you do it? Anybody know the answer? The final answer, sine 37 times cosecant 37. Answer is, what is it? I can't hear. I hear whispers. 1. Alyssa. Well said. 1 is correct. Why is it 1, Alyssa? Just feel the 1, huh? Upside down, huh? Yeah, totally. Because cosecant is 1 over sine, huh? Exactly. They just cancel. It's 1. I have no idea what sine 37 is, but I don't need to know. They're opposite. They're upside down of each other. So they just cancel. It's 1. That's all they're doing is they're testing to make sure you know. Those are upside down functions. Right on. Good. So they're gonna start doing stuff like that now. They're gonna just little properties. So we don't even need to. Okay. So we have cosine 425 times secant 65. This is more tricky now. Now you might think it's just 1. It probably is. but it's not so obvious why, because those aren't the same angle. You might think, well, secant's upside down. Yeah, it is, but those aren't the same angle. So let's start there. Let's say secant is 1 over cosine. I agree with that. But I can't just cancel these right now because those aren't the same angle. But what do I do next?
You subtract it by 360.
Subtract the 360. Right, Michael, right? Yeah, subtract the 360 because that 425 is more than a full circle, isn't it? So let's find out where that is within one rotation. So subtract the 360 for 65 degrees. So that is cosine 65 times 1 over cosine 65. So, yep, it's 1, which we guessed anyway. Good? So they're just being a little more tricky there. They're going to get even a little more tricky. Well, a fair bit more tricky. All right, sine of minus 62 over cos 422 plus tangent 242. How can you do all that without a calculator? Well, properties. Properties. Any ideas what the answer is? When you look at that and you think, there's a negative there, and sine over cosine is kind of like tangent. And I know the angles are different, but, we got all that 360 stuff. I bet this is going to end up being the same as this. Do you just feel that? I don't know, maybe I've taught for 25 years and I've seen so many of these problems. I can almost just feel the answers probably. So maybe you're not feeling what I'm feeling. But as I'm looking at that, I'm like, I know how these guys write these problems. This and this are going to end up being the same, except this one's going to be negative. So what happens when you add two things that are the same and one of them is negative? And you get 0. Can you just feel a 0 coming? Just trying to help you have a general feel. Do you just feel it's going to be a negative number and a positive? They're going to be, you just kind of tell, even if you don't know. Now, I'm going to give you all the details. But I also want to help your sense in the beginning. You go, look. Sine over cosine, that's tangent. I mean, I know the angles aren't the same, but I bet it all works out somehow with properties to where that's just going to be tangent, except for that negative. And remember, that'll come to the front because he's an odd function. So it's going to be negative tangent. This is positive tangent. It's going to be 0. I bet you, if I don't have time on the test, I'm going to guess it's 0. I bet this is 0. All right, let's go through the details. It is 0. Let's go through the details and see why. So, yeah, what I just said, negative, that could just come to the front, can't it? Now, maybe that bugs you. Maybe you're like, that even odd stuff. I'm not sure I'm going to remember that. Okay, let's do it without that, because you don't have to really remember that. You could just say, well, maybe you do have to do that. Maybe I'm wrong. No, you better remember that. Yeah, I mean, I could show you some fancy stuff. It'd be harder. Yeah, just yank that negative to the front, because sine is an odd function. Remember, cosine's even, and his upside down. The other four are odd, which means negative comes to the front. So that's negative sine 62 over, and what are we going to do with that 422 down there? Subtract 360. That'll leave 462. So then we got negative sine 62 over cosine 62. Everybody good so far? Plus tan 242. Everybody good so far? You see what I've done is pulled the negative to the front, subtracted 360. And what is sine over cosine? Tangent. So we're getting close. Can you feel it coming? This is minus tangent 62 plus tangent 242, right? At this point, now this 242, he is not more than 360, so we can't subtract 360. But there's one more property you need to know to finish. They're pushing us pretty hard on the properties here. Do you know that, why do we subtract 360? Like over here, why did I subtract 360? Well, because it's a full circle, and all the values just repeat, right? Like if you're doing the unit circle, wherever it is, unit circle there, right? Like if you're here, and you got your cosine and your sine or whatever, and you say, I'm at 60 degrees. And you say, oh yeah, well, I'm at 360 plus 60. Well, the cosine and the sine are still going to be the same, aren't they? They just start repeating after a full circle. All the cosine sine values repeat. Right. Did you know that tangent repeats after only half a circle? That's the property you need to know. So you can subtract 180 from tangent. He repeats sooner than that. He repeats after only half a circle. So that's the property. So let me write that down. Sine, cosine, they're upside downs, cosecant, secant. Their periods, which is their cycle of repeating values, is 360, or 2 pi. But tangent, and his upside down, cotan, their period, their cycle of repeating values is 180. They repeat sooner. After they don't even need a whole loop to start repeating. They repeat after only half a circle. Wow. Tan and cotan. So there's a helpful fact. Put that in your 3x5 card. So what does that mean? That means I can subtract 180 from tan, and whatever I get is going to have the same tangent. See the difference? And guess what I'm going to get? 62. You see the trick now? So we've got minus tan of 62 plus tan of 62. Now it's for sure a big 0. As we smelled coming. We knew it. And there's the proof. It is 0. That makes sense? Couple tricks there. So negative had to jump to the front because sine's odd. And then the 360 from cosine. And then tangent cycles 180. Which means tangent of 62 is the same as tangent 242. Good? All those properties. All right. Cotan of theta is 4. What's cotan theta? Plus cotan theta plus pi. Pi. How much is pi? Half a circle, right? 180. Plus cotan of theta plus 2 pi. Any guesses? They're telling me that cotan itself is 4. So this is 4 right here, clearly. Plus, what's this? Got to be 4 also. Why? Because it's only pi later. Remember, values repeat every pi, every 180. Pi is 180 degrees. Remember, for tan and cotan, if you add or subtract, if you go a half a circle more, pi is half a circle, pi is 180. It's going to be the same value again. They're going to repeat values. So whatever theta is, I have no idea, but the cotangent of it is 4. So if I go 180 more, pi more, it's going to be the same cotan. It's not going to change. That's what it means for the cycle of tangent to be pi or 180. It means if you add pi or add 180 to the angle, you're back to the same value again. And guess what this one's going to be? 4, because it's just 2 pi. Just 2 half circles. It's going to come back to the same values again. This is 12. We're done. Does that make sense? They're just hitting on the fact that the cycle or the period as they call it, for tangent and for cotan is pi or 180. So if you add pi or add 180 to any angle, you're going to be back to the same cotangent or tangent value. If it was 4 at theta, it's going to be 4 at theta plus half a circle. It's going to be 4 at theta plus 2 half circles. That good? You guys are giving me the poker face. I'm assuming that's good, but you're not looking too happy about all that. All right. Is that the answer? So, when is cotan of theta not defined? What do they mean not defined? Well, what is cotan equal to? Cosine over sine. Remember, it's upside down of tangent. Tangent sine over cosine, so cotan is cosine over sine. Okay, great. So what? Well, how does a fraction ever become not defined? Undefined, in other words. 0 where? In the bottom, right? Denominator, which is sine, must equal 0 to be not defined. Remember when the bottom of a fraction is 0, that's undefined? You can't divide by 0. It's an error in your calculator. So basically, when they're saying, hey, where's cotan undefined? I think, well, cotan is cosine over sine. So it must be where sine is 0. Because if the bottom is 0, bottom of a fraction is 0, yeah, that's undefined, not defined. So where then is sine 0? So we're at whatever angles theta makes sine 0, then yeah, that'll make the whole cotan undefined, because that's the bottom of a cotan. Where's that happen? Let's go look at your best friend, the unit circle, which will be on your 3x5 card in a week, right? So where is sine 0? Remember the first number is cosine, the second is sine. Cosine, sine, cosine, sine. So where is the sine anywhere? 0. Cosine, sine, right here. And right here. Cosine, sine. Pi and 0. Huh. So because why? Because that's the height. This point has a height of 0. Remember, sine is height. Cosine is x, sine is y. Y is sine, height is sine. This point has a y value, a height of 0, doesn't it? This point also has a height of 0. A y value, a sine of 0, doesn't it? So those two dots and any further rotations that land there. So it's 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. As you keep going around another half circle, you'll always be at some place where the sine is 0. So that's why I say it's multiples of pi, or 180. Like 0, pi, 2 pi, 3 pi, etc. Any multiples of pi. Good? I'm going to move on. If you're okay. I already answered it. This is where I filled in the answer. They had options. They had multiple choice options. I filled that in. Yeah, range, for the range, you really need to know the pictures. So, you remember the sine. What does the sine look like? Remember this? That's the sine graph. Cosine's the same thing, it's just shifted. Remember that? So I'll just say sine and cosine are like that. They go from a -1 on the bottom to a +1 on the top. Remember them? -1 to +1. That's their range. Range is up and down coverage. Remember range? You asked me for range. Range is vertical span. Bottom to top. Range for anything. Now that's for sine and cosine. They're not asking me sine and cosine. They said cotan. Well, anybody remember cotan? I'm trying to remember myself. Pi over 2. So we just said it was undefined at 0, yeah. So what it is, cotan has these asymptotes at 0 and then at pi. Remember we just said cotan is undefined? Remember back here, what did we just say? We said cotan is not defined at any of these, huh? Remember when things are undefined, they have a vertical there, don't they? Vertical asymptote. Remember that? All this math kind of coming together for you we've studied this semester? When something is undefined on its graph at these places, there's got to be a vertical asymptote. So that means at 0, at pi, at 2 pi, etc., there's vertical asymptotes for the graph of the cotangent function. Okay? And then what he does in between is a snake-like thing, an upside-down snake. I think it's upside down. I can't exactly remember. Anyway, I'm pretty sure that's right. It's either right side up or right side, and it doesn't matter. It doesn't change the answer to our question. So what's the range? If that's the graph of the cotan, you can just put that in your 3x5 card. That's the graph of the cotan function. What's the range of that function? What's the lowest? Remember, range means, remember range is right here. Top to bottom, or bottom to top, however you want to say it. How low does it go? Well, this arrow says I go down forever. And this arrow says I go up forever. So the range is all real numbers. It goes as low as you want and as high as you want. The cotangent function's range is forever up and down. That good? On that? Questions I can answer? Oh yeah, I do have it right. That is the right direction on the snake. That's right. That's correct. Okay. All right. right. Is the function even, odd, or neither? We said it's odd. Okay, now what is an odd function? What kind of symmetry? Top 4 answers on the board. I'm doing the Family Feud voice here. I don't know if you noticed. I have a 14-year-old son that loves Family Feud. Isn't that weird for a 14-year-old boy? I always kid him. And you know what he gets? We've always kidded. He's our middle child. No, he's my 4th. Anyway, and we've always, my oldest son and I always kid Johnny, my 14-year-old, that he's going to be a gambling fool when he gets older because he's always lured in by all the money things. Like anytime we're at a pizza place throughout the years, he's always over there pumping the quarters into the machine, swearing he can roll the random little things and get the little prizes out or grab the little claws. And we're always like, Johnny, you're going to waste, me and Daniel, Daniel's 22, we're always like, John, you're going to waste your money. Those machines are not going to pay. You're not going to, just, no, I almost got it last time, Dad. I'm going to get it. Just give me 2 more quarters. And this is coming out of your pay. You'll okay, yeah, I can get it, Dad. And then he'll waste like $3 or $4 or $5 on the machine and come back with nothing. Anyway, it's the same thing with Family Feud. I was watching Family Feud with him, and he's like, Dad, Family Feud is really great. I'm like, what do you mean? It's kind of a dumb show. I mean, it's kind of entertaining, I guess. And he's like, yeah, but you know what if they win? They get $20,000. His eyes are all lighted up. I'm like, Daniel's right. You're just obsessed with money, huh? Anyway, telling you my family's. Anyway, he cracks me up, 14-year-old boy. All right, so top 4 answers on the board. What's the symmetry there? What kind of symmetry does it have? Odd functions? Remember odd functions? What's an odd function? Like x cubed? Remember it's like odd powers? Think about x cubed. You don't have to remember everything, but just remember x cubed. What's x cubed look like? Remember the graph? Snake, x cubed. What kind of symmetry is that? Anybody remember? Is it y-axis symmetry? Here's the y-axis. Is it the same on both sides of the y-axis? No, that'd be over here. Is it the same on both sides of the x-axis? Here's the x-axis. No, that'd be down here like that. Same top and bottom of the x-axis. It's the other kind. What's the other kind? Origin symmetry. Remember? 2 quadrants away? Maybe don't remember. So you need to study for that final. It's been a while, been a couple months since we talked about origin symmetry. Odd functions like x cubed and like sine, which is an odd function, any odd function has origin symmetry. Odd means you have origin symmetry. You can see it on the graph of sine. Sine starts here, goes like this, goes down here. See, up here to down there, 2 quadrants away. All this is repeated down here, isn't it? 2 quadrants away. Origin symmetry. All right. Got to put that kind of stuff on your 3x. For the final, you get a full sheet of paper. Right? Okay, here we go. F of negative a. Okay, it's just weird the way they're set. They're trying to fool you with all their terminology. Let me cut through the fog. What is the function we're talking about? Tangent. So when you see f of x on this problem, just think tangent. So when they say f of negative a, you just think tangent of negative a. That's what it really is. Right? Because they said right here the function is tangent. So when they say, hey, what's the function with negative a plugged in? Well, it's tangent. Okay, so what? So if you put negative inside tangent, remember what tangent is? Tangent, cotan, sine, his upside down, cosecant, they're all odd, which means the negative goes to the front. The negative doesn't vanish, that's cosine. The negative goes to the front. So this negative comes out here to the front. It's negative tangent of a. Well, so what? Well, tangent of a is 14 because f of a is 14. F is tangent. They said it right here. Right? So this is negative 14. Negative 14. Does that make sense? They told me when you put a into the tangent, into f, but f is the tangent. That's what they said here. You get 14. So put a into the tangent, you get 14, and the negative's in the front now. So then, and then part B is f of a, which is 14, plus f of a plus pi. What happens when we add pi to tangent? Nothing changes. That's half a circle, 14. And f of a plus 2 pi, another 14. Whatever that is, 42? 42. All right, we got to move on.